Good morning. Welcome to GATE video. This is my GATE video. Myself Ms.P.RUBASUDHA, working as an assistant professor in Department of Computer Science and Engineering in SAEC Engineering College. Today I am going to cover the topic tree traversal and binary search tree in data structures. And these are the topics I am going to cover. First, I am going to give you introduction about data structures, and then trees, and what is binary tree, and what are the different types of binary trees, that is binary search tree and tree traversal. I am going to explain 5 problems in GATE class. And then first is data structure. A data structures is nothing but it is a way of organizing data in a computer. So how we are going to store a data in a computer? Why we are storing and arranging data in a computer means to organize. If you want to search any data, where we can easily search the data from the computer. If you want to insert any data into the computer, with the help of data structures we can able to insert easily. So this is the main use of data structure, the organizing data in a computer. So this is in this your data structure is divided into 2 types. One is primary data type and another one is non-primitive data type. In primitive data type, integer, float, character, pointer. These are the 4 different primitive data types, and in non-primitive data types it is divided into 3 types, that is array, list and files. In list, that is again subdivided into linear list, non-linear list. In linear list we are having 2 different types of data structure, that is stack and queue. Stack follows first in first out principle and queue follows last in first out principle. And then next is your non-linear data structure. A non-linear data structure, it is again divided into graph and trees. Today I am going to focus on trees. So first is tree ADT. In tree ADT, first I am going to give you difference between linear and non-linear data structure. In linear data structure, the data are organized in a sequential order. So here the data, whatever you have stored in the computer, that is stored in sequence. Sequence means one after another, that is stored. That is linear data structure. Another one is a non-linear data structure. In non-linear data structure, the data are stored in random manner. That is, wherever the empty space is there, in that place the data is stored. With the help of pointers we are going to connect the first data to the second data. And then this is your definition of your tree data structure. Your data structure is nothing but a collection of nodes which is organized in hierarchical structure. Here it forms a parent-child relationship. So this is your definition. Here in this, here each node we are going to store a data, and then a link is nothing but a connection between 2 nodes. I will give you an example for this, and this is your examples of your tree. So in this A, B, C, D, E, F, G, H, I, J, K, these are your nodes. And then the line connecting between 2 nodes is called a link. That is A and B having a line, that is one second. Here A, B, C, D, E, F, G, H, I, J, K. These are your different nodes. In this tree totally we are having 11 nodes. And then A to B there is a connection, and A to C there is a connection. B to D there is a connection, B to E there is a connection. These are the links that connects 2 nodes. This is called edges. So whenever there is a tree contains n node means then there is definitely a n minus 1 edges. So in this the total number of edges is 10 and the total number of nodes is 11. So it follows n into n minus 1 principle. And then next I am going to explain what are the different terminologies used in the tree. The first terminology is root. So root is nothing but that is the first node in the tree. That is your root node. So consider this example. In this example the first node is A. So A is your root node. We are going to call the A node as root node. So that is the first node in our tree. And then next is edge. Edges is nothing but a connection between 2 nodes, that is similar to link. So here AC having a link, that is called in tree we are going to call it as a edges. So likewise in this tree we are having totally 10 edges. And then next is parent. So your parent is nothing but a node which is a predecessor of any node. That is called a parent node. That means a node which has a child. That is called parent. Here A has a child of B and C. Then A is a parent node. And then likewise B has a child of D, E, F. So B is a parent node. But D is not a parent node because D doesn't have any child. So here in this tree, D, I, J, F, K, H, these are not a parent node because that node doesn't child. So this is your parent. And then next is your child node. Child node is nothing but a node which has a descendant of any node. That is called a child node. So here descendant of any node means here in this example B and C are children of A and G and H are children of C. So here G and H are child and C is a parent, and B and C are child and A is a parent. So this is your child concept. And then next is your siblings. Siblings is nothing but with a node which belongs to the same parent. Here B and C are siblings because B and C parents are A. So here in this example B and C is your siblings. Likewise D, E, F. These three nodes are also called siblings because the parent of D, E, F is B. And likewise I and J is your siblings because the parent of I and J is E. And then G and H is also we are going to call it as a siblings because the parent of G and H is C. And the next is leaf node. A leaf node is nothing but a node which doesn't have a child. That is called a leaf node. So in this tree, D, I, J, F, K and H. These nodes are called leaf node because there is no other node in the next level. So this is called a leaf node. And then next is degree. So a degree is nothing but total number of children of a node. That is called degree. Okay, consider the degree of B. We are going to calculate the degree of B. Here the degree of B is 3 because the total number of child for B is 1 minute. Because if you want to calculate the degree of B, we need to check the number of children. Here D is first child and then E is second child and F is third child. So the degree of B is 3. Likewise, we need to calculate for each and every node. Suppose if you want to calculate the degree of E, the degree of E has 2 child. One is I, another one is J. So the degree of E is 2 child. So then the degree is 2. Likewise, we need to calculate for each and every node. If you want to calculate the degree of the whole tree, from this you need to take the maximum value. That is your degree of the whole tree. Next is level. So here level is nothing but here each and every node are arranged in hierarchical order. So here in first level we have stored the root node, that is A is present in the level 0, and then in second level we are going to store the next 2 nodes, that is B and C. This level is called level 1. Likewise in each and every level we are going to store the left and the right sibling of each node. So in this example, this is A is present in level 0 and B and C is present in level 1, and D, E, F, G, H are present in level 2, and then I, J, K are present in level 3. Next is height of the tree. Next is we are going to find the height of the tree. Here if you want to find the height of the tree, we need to focus on the number of edges. Number of edges is nothing but the link between the nodes. If you want to calculate the height of the whole tree, we need to focus from root to leaf node. Here consider I am going to focus on A to I. So I am going to find the height of the tree from A to I. So here from A to B I am having a path, and then B to E I am having another path, and then E to I am having path. Here in this total number of edges is 3. So if I want to go from root node to leaf node, I can use 3 edges to reach the leaf node. So this is how, likewise only we need to find the height of the tree. Suppose if in right subtree, if you are having 4 edges, then the height of the whole tree is considered as 4, because we need to take the maximum number of edges in the tree. Next is path. Your path is nothing but the sequence of nodes and edges from one node to another node. That is, we are going to find the path from source to destination. Consider here I am going to find the path from A to J. Okay, from A to J I am going to travel. So in this I am going to first move from A to B, and then B to E, and then E to J. So I have reached the destination. In this my path is A to B, B to E, and B to J, E to J. This is my path. Suppose if I want to travel from A to K, then I can go for A to C, C to G, and then G to K. This is my path. Likewise you need to find the path of every tree. And then next is types of tree. In trees, your tree is generally divided into 3 types. One is binary tree, ternary tree, another one is n-array tree. So your binary tree is nothing but a node which contains 2 child. That is called binary tree. Either 0 child or 1 child, 2 child, but not more than 2 child. That is your binary tree. And then your ternary tree is a tree which contains either 2 or 3. Okay, but it should not more than 3. That is your ternary tree. And then n-array tree means a tree can have many number of child. More than 3, if you have any number of child, then that tree is called a n-array tree. Now we are going to focus on binary tree. So here this is your definition of your binary tree. In binary tree, here binary tree is nothing but which contains at most 2 child. So here binary tree contains at most 2 child. Here in this we are going to call it as a left child and right child. Consider this example. Here this is an example of your binary tree, because for each and every node only we are having 2 subdivision. One subdivision is called left subtree, another subdivision is called, we are going to call it as a right subtree. Here A having only 2 subdivisions. So this left, we are going to call it as a left child. So A to B is called left child, and then A to C is your right child. Likewise for each node, either it contains 0 child or 1 child or 2 child, not more than 2 child. So this is your concept of your binary tree. So in this binary tree, we are going to focus on tree traversal. So your traversal, what is the meaning of traversal? Means traversal is nothing but we are going to visit a node. Visiting, that is your traversal. So your traversal is nothing but visiting each node exactly only once. That is your traversal. In this traversal, we are having 3 types of traversal. First one is in order traversal, second one is pre-order traversal, third one is post-order traversal. So in order traversal means we need to follow this principle. First we need to visit the left node, and then root node, and then right node. Okay, consider this is your tree B, A, C. Okay, in this your B is your root, and then A is your left, and then C is your right. This is your tree. So first we are going to follow the principle in order traversal. So in order traversal means first we need to visit the left node. So for this node, your left is A. So first we are going to visit A, and then root. We are going to visit the root node, that is B, and then we are going to visit the right node, that is C. That is C. So this is your in order traversal. And the next one is pre-order. Pre-order is nothing but here we need to follow. First you are going to visit root node, then left node, then right node. This is your principle. So first I am going to visit the root node. Here the root node is B, and then your left node is A, right node is C. So likewise we need to visit. And the next is post-order traversal. In post-order traversal, first we are going to visit left, then right, then root. So here first left node is A, and then right node is B, and then right node is C, and then your root node is B. So A, C, B. Likewise we are going to visit the node. In this, if you want to remember, you can use this trick. In order traversal means in between you are having a root node. Pre-order traversal, pre means before. So before we are having a root node. Post means after. So at last you are having a root node. Likewise, you need to remember this technique. And then this is your algorithm to perform your tree traversal. First one is, first we need to visit the left subtree. That is first we need to visit the left subtree, and then we are going to visit the root, then we are going to visit the right subtree. The same concept, but here the tree traversal can be applied in recursive manner. In repeatedly we are going to execute this. So this is a recursive function. We need to call the left subtree again and again. After finishing all the subtrees in the left side, then only we need to visit the root. Consider this example. Here we are having A, B, C. Here again I am having nodes D, E and then F. Okay, so here A is your root node, and then B, D, E. These nodes are called left subtree. If you are having only one node, then that is called a left child. If you are having many nodes in the left side, then that is called a left subtree. Again likewise in this is called a right subtree. Okay, now apply the algorithm. First we need to traverse the left subtree. Traverse is nothing but visit. We need to visit the left subtree. Left subtree in the sense we need to visit all the nodes in the left subtree. That is D, E, B. After visiting all the nodes in the left subtree, then only we need to move to root node. That is A. And then after visiting root node, then only we are going to visit all the nodes in the right subtree. That is the concept. And the next is pre-order. In pre-order, first we need to visit the root node, and then left subtree, and then right subtree. So first we are going to visit the root node A, and then all the nodes in the left subtree we are going to visit. After visiting all the nodes in the left subtree, then only we are moving to right subtree. Next is post order traversal. In post order traversal, first we are going to visit the left subtree, then right subtree, then the root node. Okay, likewise we need to visit. Next is, again this is one example for your understanding. I will explain this. First I am going to apply in order for this. Okay, first I am going to apply in order. The formula to calculate your in order is left, root, right. This is your in order traversal. So here first always your traversal can be start from the root node. So first you need to check from the root node. Here root node is 1. So this is your root, and this is your left subtree, and this is your right subtree. So first I am going to visit all the nodes in the left subtree. Okay, so first apply in order for this root node. So root node, if you want to apply in order, means left, root, right. So first you need to go to the left side. Again apply in order for 2. Again left, root, right. Again move towards the left side. Again apply in order. This is your leftmost node. So if you want to find traversal, in order traversal, you need to come to leftmost node. So in leftmost node apply in order. If you want to apply in order, means your formula is left, root, right. Here for node 4 there is no left, there is no right. So directly we are going to visit the node 4. After visiting 4, next we are going to move to the previous node. Okay, now I have visited this 4, so I am going to mark it as a star, and then now I am moving to 2. So now I am going to apply in order for this 2. So your formula is left, right, root. So here for 2 your left is 4, that is already visited. Next I need to visit the root node, that is now the root node is for this subtree, our root node is 2. So next I am going to visit 2. And the next is I need to visit right. The right for the node 2 is 5. So next I am going to visit 5. Now all the nodes in the left subtree is visited. After visiting this, again I'm going to move backwards. Now this is my root node. Now apply same in order principle. First we need to visit the left. Here now all the nodes in the left side are visited. Next I am going to visit the root node. Root node is 1, and then I am going to visit the right subtree. In right subtree I am having only one node, so I am going to visit this. So this is your in order traversal. Next is pre-order. Pre-order means first we need to visit root, left and then right. So first I am going to visit the root node. First I am going to visit the root node. Here the root node is 1. So first I am going to mark it as visited. After visiting root node, I need to move on left side. So in left side, this is my next node. Now again I am going to apply pre-order. So if you apply pre-order, again you need to visit root, left, right. Here this is your root node. So first I am going to visit the root and then I am going to focus on left. After visiting root, I need to focus on left. So in left side I am going to move. Now again I am going to apply pre-order. So if you apply pre-order, you need to visit root, left, right. Root is 4. There is no left and no right for 4. So after visiting this node, I need to move backward. Now I am going to again check for 2. So for 2, root, left, right. Root is visited, left is also visited. Next I need to visit my right side. Right is 5. Likewise I need to visit. After visiting all the nodes in the left subtree, I need to move to the right side because we have visited root, left. In left side I have completed all the nodes and then right side I need to move. In right I am having 3. So I am going to visit the node 3. This is your pre-order. And then next is post-order. In post-order, your formula is first we need to visit left, right, root. Okay, this is your format. So first I am going to start from the root node. So first I need to visit the left node. So in left side I need to move. For this node, again I need to move to the left side. So like in order, you need to focus on the leftmost node. So now I have reached the leftmost node. Now I am going to apply the post order for this. Now apply for post order for this node. Your post order formula is left, right, root. For this node, no left, no right. So we need to visit the root node. Your root node 4 is visited. And then again we need to backtrack to the 2. Again, now I am going to apply post order for this. If you apply post order for the node 2 is you need to visit left. Left is already visited. Next I need to visit 5, that is right. After visiting left and right, next I need to visit the node 2, that is root node. So root is visited. So after visiting all the nodes in the left side, I need to go to right side. So in right side, I am going to visit the next node, that is 3. After visiting all the nodes in the right side, I need to go to the root node. Then the root node is 1. This is the order you need to visit. And this is one more example. And this is a simple trick to follow the tree traversal technique. Consider the flag is set in the each node. Consider if it is a pre-order. Consider if it is a pre-order, you need to set flag in left side. If it is a post order, you need to set flag in the right side of each node. If it is a in order, you need to set the flag in the middle of each node. Okay, this is a simple trick to check whether your answer is correct. Okay, so first consider this example. Now I am going to apply in order. I am going to apply pre-order. Pre-order means in left side I need to put a flag symbol. So here I have put a flag symbol. So now I am going to start visiting from the root node. I need to simply draw a line from starting from root node by crossing all the nodes. Okay, wherever the line touches, that is the order that the tree is visited. Okay, now this is the order. The flag first touch the line is A. So first A node is visited. And the next is B. Next I have touch the flag symbol is D. So A, B, D. And then E. Next C, F, G. Likewise you need to check your answer. And then next is in order. In order means you need to set the flag in the middle of each node. So here I have set the flag in middle of each node. Now I am going to traverse in the same path. I am going to draw a line which covers all the nodes. Okay, now I am going to check whether which node touched the first flag. So now first the D node is touched the flag, and then B, next E, and then A, F, C, G. So this is your in order. And the next is post. For post you need to set a flag in the right side. So right side set a flag for each node. Now draw the same line starting from root node. So first the D node is touched. First the D flag is touched and then E. Next we are going to touch the B node. So next node visited is B and then directly come to F. Here F is touched and then G. After visiting G only we are going to move to C and A. So C, A. This is the way you need to check your answer. And the next is binary search tree. In binary search tree, it is also one of your type of your binary tree. Binary tree is nothing but a node which has at most 2 child, either 0 child, 1 child or 2 child, not more than 2. So in this, it follows a condition. What are the values that is present in the left subtree must be lesser than the root node, and then what are the values that is present in the right subtree must be greater than the root node. So this is the principle we are going to apply in binary search tree. Other than this, it is similar to your binary tree. So, and this is your example. Here, check, this is your root node. This is your root node. So, in root node, we are having 25. Now, check this left subtree. All the values are lesser than the root. And then check this right subtree. All other values are greater than the root. Likewise, we need to insert into the tree. Next, directly we'll move to problems. So this is your first gate questions. This is asked in 2015 and 1996. The first question is, the following numbers are inserted into an empty binary search tree in the given order 10, 11. In the given order 10, 1, 3, 5, 15, 12, 16. So this is your numbers. We need to insert the elements into the binary search tree. And then we are going to find the height of the binary search tree. So here height of the binary search tree is nothing but it is similar to height of binary tree. So if you want to find the height of binary tree, total number of edges from starting to leaf node. That is your formula. So first draw the binary search tree. First node is 10. So that is the root node. Your second node is 1, that is lesser than the root. So we are going to insert in the left side. Whatever the values that is lesser, we are going to insert in the left. Whatever the values that is greater, we are going to insert in the right. That is the principle. So 1 is inserted in the left side. And then next again we need to insert the third value. Third value is 3. First check with the root. 3 is lesser than the 10. Go to left side. So and then 1 compared to 1, 3 is greater than 1. So insert in the right side. And the next value is 5. 5 is again start from the root, you need to compare. So compare 5 with the 10. Here the value is lesser than the root. So come to left side and then again compare with the next node. Now the value 5 is greater than the 1. So move to right side. So again check the value. Here 3, the number we are going to insert is 5. It is greater. So we need to insert in the right side. And the next is 15. So 15 is start from the root, you need to compare. So 15 is greater than 15 is greater than 10. So in right side I am going to insert 15. And the next is 12. 12 is greater than 10. So right side, but it is lesser than 12. So in left side we need to insert 12. And the next node is 16. 16 is compared with the root node. It is greater. So obviously we are moving to right subtree. In right subtree, compare with 15. 15, if you compare with 15, it is greater. So we are going to insert in the right subtree. So this is your binary search tree. So in this binary search tree, we need to find the height of the binary search tree. So height of the binary search tree is nothing but starting from root to leaf node. So this is your leaf node. So here the number of edges we have crossed to reach the leaf node is 1, 2, 3. So then your answer is 3. Likewise you need to find out. Next is your second question is, this is asked in 2015 and 1996. This binary search tree is constructed by inserting the following sequence of numbers. This is your numbers. In this we need to find out the number of nodes in the left and the right subtree of the root. So after drawing the binary search tree, we need to find the left and the right subtree nodes. So first draw the binary search tree. Initially the root node is 50 and then the value 15 is lesser than 50. I'm going to insert in the left side, and then value 62 is greater than 50. I'm going to insert in the right side, and then next I'm going to insert the next value 5. Compare with root, it is lesser. Again compare with 15, it is lesser. Now I'm going to insert in the left side, and then next 20 compare with root node, it is lesser, but compare with 15, it is greater. So I'm going to insert in the right subtree. And then next is 58 compare with the root node, it is greater, but compared with 62, it is lesser. So I'm going to insert at the left side. And then next again insert the next value 91 is greater than, so I'm going to insert at the right side of 62. And then 3 lesser than 50, lesser than 15, and then lesser than 5. So here I'm going to insert 3. And then next I'm going to insert 8 is right of 5. And then next is 37 is lesser than 50, greater than 15, greater than 20. So in right side 20, I'm going to insert 37. And then next is 60 I'm going to insert in the left side, in the right side, because that is greater than 50. In right side 62, if I compared with 60, it is lesser, but it is greater than 58. So I am going to insert in this after in the right side of 58. Next is 24 is lesser than 50. So come to 15, again compare, it is greater, but it is again greater, but compared to 37, it is lesser. So here I am having 24. Now I need to check number of nodes in the left and the right subtree. Here this is your left subtree. In this left subtree, these are the nodes I am having. The total number of nodes is 1, 2, 3, 4, 5, 6, 7. So 7 is the left subtree. And then next is in the right subtree 1, 2, 3, 4. So 7, 4, B is your correct answer. So next is your third question. While inserting the elements 71, 65, 84, 69, 67, 83 in an empty binary search tree, the elements in the lowest level. So here we are going to insert a binary search tree. After inserting, we need to find the lowest element, that is the leaf node. So for again use the same principle to insert binary search tree elements. So 71, 65 is lesser, and then 84 is greater, 69 is greater than 65, and then 67 is lesser than 69. Next is 83 is lesser than 84. So now in the lowest level, in the bottom level, this is level 0, this is level 1, this is level 2, level 3. Okay, in level 3 we are having 67. So option B is your correct answer. Next is this is the fourth question. This question is asked in 2000. So let last post, last in, and last pre denotes the last vertex visited in a post order, in order and pre-order traversal, respectively of a complete binary tree. Which of the following is always true? Here they have given some conditions. Here last post represents the Here last post represents the last node in the post order, and then last in represents the last node in the in order, and then this is last pre represents the last node in the pre-order. So these are the three terms they have given in this. Here we need to focus on complete binary tree. So in complete binary tree, we need to find the tree traversal, that is in order, pre-order, post order. After finding tree traversal, we need to check which option is correct. Okay, let's see. Okay, consider this is your complete binary tree. Your complete binary tree is nothing but here all the levels are completely filled except possibly the last one. Here consider this is your level 1. Here level 1 only one node, in level 2 2 nodes are filled, in level 3 3 nodes are filled except the last level, that is right of the C is not filled. So this is your example of your complete binary tree. In this complete binary tree, I am going to find the pre-order, in-order, post-order. So to find pre-order, in-order, post-order, use the flag method. That is very easy to find out. So first I am going to apply pre-order. Pre-order means before I need to set the flag symbol. Okay, first in the left side I have assigned the flag symbol. Now I am going to traverse the node. So first I have touched the line is A, and then B node, next D node, E, C, F. So this is your pre-order, and then next for in-order. In-order means I need to draw a flag line in between. So in between I have drawn a flag line. Now I am going to start traverse from starting to till the end. So here first the line touched is D, next B, next is E, then A, next F, and then C. So this is your in-order traversal. Next is post order. So in post order means you need to draw the flag at the right side. So right side draw flag. Okay. Now we are going to traverse. Okay. First the flag touched is D. So first visitor node is D, and then E. Next we have moved towards B. Next is F, C, A. F, C, E. So this is your order. Here, now check your pre-order. At last you are having 1 minute. In pre-order, the last node we have visited is F, and then your in-order, the last node visited is C, and then your post-order, the last node visited is A. So here I have assigned this value. So last post equal to A, last pre equal to F, and then last in equal to C. Now I'm going to compare with the options. So your first option is last in equal to last post. Here last in is C, C equal to last post is A. So this is not equal. So first condition is false, and first option is false, and then next is last in is C, last pre is F. So this is also false. Next is last pre is F, and then last post is A. So F is not equal to A. This is also wrong. So obviously none of the above. This is your right answer. And then next is gate question. This is asked in 2003. So suppose the number 7518360942, these are the numbers we are going to insert in the order, and initially empty binary tree. The binary search tree uses the usual ordering on natural numbers. What is the in-order traversal sequence of the result? So first in this order we are going to insert. So first we are going to insert binary search tree in this order itself. So initially a root node is here 7. So likewise we need to insert after inserting binary search tree, we are going to find the in-order traversals. So among this, which traversal is correct? Likewise we need to find out. Now consider this. First I am going to insert 7. 7 is my root node. So root node is inserted, and then next is I am going to insert is 5. 5 is lesser than 7. So in left side I am going to insert, and then 1. 1 is again lesser than 7, lesser than 5. So in left side I am going to insert 1, and then next is 7. 8 is greater than 7. It is inserted in the right side, and then 3 is lesser than 7, lesser than 5, but it is greater than 1. So I am going to insert at the right side. Next is 6 is lesser than 7, but it is greater than 5. So in right side I am going to insert. Next is 0 means again it is a number, don't neglect this. So compare with 7, lesser, compare with 5, lesser, compare with 1, again it is lesser. So you need to insert in the right side. Next is 9. 9 is greater than 7, greater than 8. So I am going to insert in the 9. And then next is 4. 4 is compared with 7, lesser, again lesser. Again compare with 1, it is greater. Compared with 3, it is again greater. So in this I am going to insert. Next is 2. 2 is again inserted in the left side of your 3 because that is lesser than the 3. So now I have inserted binary search tree. Now I am going to find the in-order traversal. One second, I will check. Yes, I am going to find the in-order traversal. In-order traversal means middle, I need to draw the flag line. Okay, now I am going to start visiting this. So first line touches this. First node touch the line, flag line is 0, 1, 2, 3, 4, then 5, then 6, 7, 8, 9. So this is the correct order. So option C is your correct answer. That's all. Thank you. We'll continue in the next video class.